Yeah, the next part of the demonstration on multi-level modeling with ConceptBase is about the Dual Deep Instantiation method that we developed in 2014, proposed in 2014. It is a quite expressive multi-level modeling scheme allowing for so-called dual potencies. So for more details about this method are on this webpage, conceptbase.sourceforge.net.ddi. We just use this simple example here on the right. So let's start it again with the graph editor of ConceptBase. I should say that this graph editor contains all the sources of the examples, including the definitions of DDI. So it's a completely self-contained representation. Yeah, so here you see object at the lowest level, like my car, that has a serial number and number of doors 4. That is an instance of a simple class car, which itself is an instance of a meta class product type. Yeah, the idea of multi-level modeling is that you define generic relations and attributes only once, ideally only once, and at the highest suitable abstraction level. And in order to specify where they are instantiated, you have so-called potencies. These are the numbers here with the names of the associations and attributes. So product type is a meta class. So let's say level 2 is level 1 and level 0. And the serial number has the source potency of 2. That means it is instantiated 2 levels below product type, 1, 2. So at the level of an object like my car 1, 2, 3. The target potency is 1. So the class here is a numeric value. So when we instantiate serial number at the lowest level, we only have to instantiate that once to reach at the level of a value, a numeric value like 4. In the case of serial number, it has 2, 1, so instantiating that 1 should give you a serial number. Here at my car, you see serial number has a potency 0, 0. It cannot further be instantiated. This is one level below numeric value, that is target potency 1, and 2 levels below product type, that is the source potency 2. We also have this number of doors that is defined for car. That is a regular type of attribute, simple class with a domain here. And when we instantiate car, we go down one level, and we also instantiate one's numeric value to reach number of doors with potency 0, 0. So this is kind of the default potency 1, 1, but we also have potency like 2, 1. Let's see how the definitions are made. So let's open the textual view. Let's make it a bit bigger. So here, product type is defined as an object that is a construct of DDI as implemented with ConceptBase. And it has a relationship with domain and range constraint. That is the meaning of linked DR that goes to numeric value. Now you see here there are source and target potency, and there's also a label serial number. That is actually encoded in the attribute here. Let's make that a bit larger. So the M1 relation of product type that is exactly 1, this one here, M1, that has a source level, source potency of 2, and target level of 1, and the label is serial number. So that is a internal representation of these properties. We have instantiation in DDI, that is working similar to the normal instantiation that is also in ConceptBase, but not exactly the same. And we have specialization. So you can also define subclasses and then define um, yeah, uh, multi-level attributes and relationships with subclasses. And this is all governed by a large number of constraints and rules in DDI. We'll have a short look at that as well. Good. Let's look at the definition of car. Yeah, that has is an object. Here we have the instantiation, that is this one here, to product type. That is an instantiation of DDI, a special construct of DDI for instantiation, and it has this number of doors. Link. Let's display that here. So that has potencies 1, 1. Finally, let's have a look at car. So that has 2 attributes here. Display that here. So that is the number of doors, instantiating the number of doors link of car. And the second one is the serial number here. Good. So you would define such a model with such frames. Yeah, in this graph, I show how we can extend the hierarchy of classes by a class mobile phone, and also showing the specialization construct of DDI. The objects here on the right have been discussed previously, and now we define a new instance mobile phone of product type. We further specialize that to digital mobile phone, and then we have an instance my phone. Member is it's a derived relationship based on instantiation, so that that honors the semantic of specialization. So an instance of a subclass is also a member of the superclass. Now here we define another type of multi-level attribute. That is a protocol that has the source potency of 1. So instances of mobile phone can use that. So my phone is a derived instance of mobile phone because it's an instance of the subclass. But it has a target potency of 2. So we have here wireless communication standard that is specialized to digital wireless communication standard that has an instance GSM standard, which has here these 4 instances like the 4G standard. So if we instantiate that once, we get to an object like my phone. And if we instantiate that twice on the target side, we get to an object like 4G. So protocol of my phone is 4G. We can reuse the serial number as shown here. Let's look at some of the sources. Make it a little bit bigger. So my phone is the direct instance of digital mobile phone and has these 2 relationships, M1 and M2. M1 is this protocol 00, and M2 is this serial number. We can also have a look at the definition of that serial number of my phone. that has a source and target potencies or level of 0. Let's look at this protocol that is also here having level 00 and the label protocol. Yeah, so DDI or Dual Deep Instantiations allows you to define attributes and relationships with potencies, source and target potencies. You can define uh, um, an attribute at a meta class, which shall be instantiated at the token or object level. You don't have to define serial number both for car and mobile phone, but you just define it at the meta class of mobile phone and car. So you save modeling work. Uh, in ConceptBase, this is defined by quite a large number of rules and constraints, and I give a short glimpse, and I refer you to this web page on DDI. That's also on the ER21 demo page for more details. So all the definitions are also in this graph file, which loads them into a ConceptBase database. So we go to the home module and then list the contents. And here you see the definition of the class object in DDI that is quite elaborate, where you saw we have used in and linked dr, but there are many more like member, spec, and so forth, and transitive and reflexive completions of these relationships. Yeah, these are some the initial constraints on abstractness, some closure rules. So if X is specialization of Y, then it's also a transitive specialization of Y, and so forth. We define here some derived relationships like member, and here is-a, or specialization. This is a function that computes the level or the number of levels between two objects, like between an object at the lowest level and a meta class. Let's skip that. We have a lot of additional syntactic constraints, like if something is a transitive specialization of C, then it may not be the same. So this is not reflexive. The is-a itself is not, is-a-t is not reflexive. These are all in the original DDI paper from 2014. And you can look up the axioms here in the paper. That is a concept-based representation of these axioms. These axioms here govern how you instantiate attributes, multi-level attributes and relationships. So it constrains the number of levels between two versions with different potencies of the attribute with the same label. So same label here. That's quite a large number of constraints. These are auxiliary queries and functions in DDI. Yeah, so that is the part on dual deep instantiation. And the next part we will look at the power type version MLT.